Hey everybody, welcome back to Young Engineers of Today. So we're actually going to continue with Over the Wire today a little bit more. We might do another one or two sessions of it, I'm not entirely sure, but we shall see. So we'll get through some more of this today. I'll spend some more time explaining it to you guys. Hopefully it'll make a little bit more sense. Hopefully it'll get a little bit more interesting. But we will go through this as much as we possibly can. I will actually start out though by giving you the password for level 6. Because that's actually where we left off last time, and if you didn't save it, there's no sense in going through the previous 6 levels in order to get to it. I said 6 levels because you start at 0. I'm not trying to be purposefully obtuse. So here we go, and we got the middle schoolers to Bandit 11 today. So let's see if we can beat that record. So okay. Hopefully you remember how to get on to Bandit Labs, or Over the Wire, I should say. I just have it saved here, so I'm going to go ahead and, bam, hit open. It's going to ask me for my login. Bandit 6. Bandit 6 is going to be the login because that is the level we're currently on. I'm going to right-click to paste the password, hit enter, and here we are. We're now logged in, just like we did all those times before. So, what do we do? Well, let's check out our level goal. The password for the next level is stored somewhere on the server and has all of the following properties. It's owned by user Bandit 7, it's owned by group Bandit 6, and it's 33 bytes in size. Well, that's a bit to unpack here, What exactly does that all mean? Well, 33 bytes in size, it's pretty straightforward. When we were using find last time around, we input a specific size that we were looking for, if you'll remember that. And we were able to get the file that we needed. So we can probably, this gives us a clue that we're probably going to be utilizing the find command again. But these owned by user and owned by group. So we've got users, we've got owners, we've got groups. Users are accounts that use a computer. Makes sense. They're users because they use. It sounds a little bit harsher than I mean it to, but anyway. Owners are people who, well, they have a certain level of permissions with the file. It can be thought of as they own the file, but that's not, confusingly, that's not always the case. But basically, they're like one step below root, which is sort of like the end-all and be-all when it comes to computer accounts on Unix systems. There are some things that even owners and administrators can't do that root access will be able to, including really scary things like mess with the operating system files and stuff like that, which can really, really seriously mess up your computer. So, you always want to be very sparing with your root access on your own computer unless you know exactly what you're doing. So there's that. But here's the deal. You can really only have one user, one owner, explicit owner, on a file. If you create that file, you are then the owner of that file. You can make it so that people who aren't owners of the file are able to look at the file and mess with it and stuff like that. But what if you wanted it so that a certain group of people, like, I don't know, people that you're working on a project with, can read and write and mess with the file, but then you wanted everybody else to be unable to even look at the file? Well, you could have an owner group. Because you can't make them all owners because you're the owner, and there can only be one owner. But you can make a group owner, and that's the way to sidestep around it. So you can attach an entire group of users to it as an owner, and a group is just a collection of users that exists in the Unix system. I know it seems like a weird concept, but it's just kind of like saying having a group of people. That's just, we can have a group of people own it. So this gives us some idea. Now let's go ahead and ls, which should list the file contents, or the contents of the folder that we're in, and there's nothing. ls-a, which should list everything. Yeah, yep, that'll happen. So what you did is you searched for anything in the root directory that had hidden in it, including all of its subdirectories, with no restrictions whatsoever, other than the fact that it has hidden somewhere at the end. Yeah, exactly, because they're very, very careful with their permissions in this game, because they want to make it so that, like, you don't open up Bandit 25 and grab the password and then skip straight to 26, so they want to make it so that, like, there's a bit of a challenge, so that's one of the things. So let's actually take a look at this. So what I'm going to do is, I can already tell that there's not going to be anything inside of this folder that we start out in, but it does say somewhere on the server. So let's try going up a level. Let's see what we got here. Now we've got a list of all of the games that are on this server. Let's try finding, whoops, just by typing find, let's try finding something 33 bytes in size. So we'll do that with the option size, and then we'll type a space, and then 33, and then C. And C is just the shorthand that means that we're looking for something that's 33 bytes in size as opposed to 33 blocks or 33 kilobytes or 33 megabytes or whatever. So let's hit enter. So here we go. We got some interesting results here. We got a fair amount of results, but we got these bandit in here hiddens, and then we've got these ones that say find, bandit 5 in here, permission denied. So when we're talking about owners and stuff like that, when you see permission denied, what does that tell you right off the bat? What are we probably not if we don't have permission to even view what's inside of these folders? By the way, that's what that is we're trying to look inside of these folders and we're not allowed to. Well, we're probably not owners of these folders, are we? So we can pretty much rule those out immediately. Now we do have some files, but just because we can see the files doesn't mean we have access to the files. We have access to the folders that contain the files, which is why we're not getting that permission denied result. But we don't have access to the actual files necessarily. Like, let's try reading cat bandit 18 readme. Let's see what happens. Uh-oh, permission denied. So even though we can see the inside of the folder that contains it, we cannot read that file because we don't have permission. Well, let's do an ls-l, which is short for list permissions, for bandit 18/readme. And let's take a look at what we got here. So we've got some dashes and an RW and an R, then we got a number, and then the bandit 19, bandit 18, and then 33, and then November 14, 2014, and then the file path. So what do these all mean? Let's take this apart for a second, because this is something, if you became like a Unix user and started working out the terminal, you'd see this at least a few times. So it's helpful to know what's going on here. So you've got things like root access, read and write access. And read and write involves things like opening the file and moving it and deleting it and stuff like that. So just, that's something to keep in mind. R is short for read, the W is short for write. Now you'll notice that we've got RW and then another R. That's because there are three classes here. We've got root, owner, and everyone else. The first one is listed for root, so root has read and write permission. The second one is listed for owner. Owner has read permission. Owner does not have a write permission, and that's something that they baked into this game so that, because there's a bunch of people playing it, they wanted to make sure that somebody didn't come along and be like, oh, hey, I got the password, and then they just change the password by one character for the next person to come along and never have it work again. Because that would be a really quick way to ruin people's fun. But yeah, so owners only have read permission even. And if you're not an owner and you're not root, you have no permissions. You have no ability to, basically, you can't even think about the file. You just got to pretend it's not there. So that's what that means. The one refers to, I believe, the number of entries on the list. Then we've got this bandit 19 and bandit 18, which is actually what I'm interested in right now. Bandit 19 and bandit 18 refer to the owners. Bandit 19 is the group, or excuse me, is the user owner. So this is owned by bandit 19. That is their username. It's bandit 19. The group that owns this is bandit 18. Now, confusingly, it's another username, but this could be called, well, I don't know, cool people or something like that. You can name groups whatever you want in Linux. For the most part. There are exceptions. But anyway, the name of this group is Bandit 18, set up by the people who made this game for simplicity in order to illustrate the fact that Bandit 18 is one of those, users in the group. But the first one is going to be the individual user that owns this file. The second one is the group of users who have ownership on this file. And then we got the 33, and we can probably infer what that is because remember we were looking for something that was 33 bytes in size. So that's probably the size of the file. It's 33 bytes. And then November 14th, 2014 is when it was made. Or rather, when it was at least uploaded to the server and created. Maybe the server had a secure copy over and then all the files were written on November 14th, 2014. So that's how old this file is. And then we've got the file path. It's located in Bandit 18 README relative to where we are. So that all makes sense, right? I mean, so far so good. So we were just looking for things that were 33 bytes in size, and we got a lot of results, including permission denieds. We can actually just flat out ignore the permission denieds, A, because we know we don't have permission there, and B, because they're not actually search results. It's just the computer letting us know, hey, I couldn't look there, so I have no idea what's in there. Whatever you're looking for, though, it's probably not in there. Because if we had permission to read the file, we should probably have permission to be able to open up the folder that contains the file. Whoops. All right, so let's narrow things down. Let's check the manual page for find. What we're interested in is something that helps us out with the fact that we need to distinguish by ownership. We need to find something that denotes that searches for files by owner or searches for files by file group, or ideally both. So let's go ahead and check the manual page. I got here by typing man find, man being short for manual, and space find, so it's the manual for find. And let's take a look here. Let's look under tests. Under group, I've got group gname. File belongs to group gname. I like that. That's good. That's a good start. Scroll a little bit more. User uname. File is owned by user uname. Numeric user ID is allowed. Yeah, don't worry about the stuff in parentheses. But here we've got group and user. Group searches by group owner. User searches by user owner. All right, let's hit Q to get out of the manual page. So, the nice thing about a lot of commands in Unix systems is you can just chain options together by adding them to the end. And that's exactly what we're doing here. We're saying find dash size space 33C space dash user space bandit 7 space dash group space bandit 6. So we're actually adding more and more sort of constraints to our search. Now keep in mind, we haven't actually looked for a file name yet or location. It's searching for any files, any file names, anything that fulfills our size and our ownership criteria in the folder that we're currently in, including all of its subfolders. So it's searching inside of home, and then it's going into bandit 0 and looking in there, and then bandit 1 and looking in there, and bandit 10 and looking in there, and bandit 11 and looking in there, and then looking inside any folders that are inside of those folders. So, you know, it's all very, it's comprehensive right now. Let's go ahead and hit enter. Find, permission denied, find, permission denied, find, permission denied, find, permission denied, find, permission denied. Absolutely 0 results, because remember, we can ignore those. Those aren't actually results, those are just error messages. So we have no results here. Well, kind of a problem, right? Well, not entirely yet, because if I type pwd to give me an idea of where I am, which is short for print working directory, hey, look at that. There's another level above, because the root folder in a Unix system is just a /, just a single /. So let's try going up a level. Boop. Now we're up a level. Let's see what we got here. readme.txt, behemoth, bin, or binaries, boot, dev, drifter, Eloy, etc., games, home, Krypton, lib, short for library, libraries, library 32, library 64, library x32, lost and found, man page, maze, media, mount, Narnia, options, processes. Just for funsies, let's cat the readme. Okay, so this is the readme that always plays at the beginning. The green highlighted one. Temporary folder is exactly that. It gets emptied out whenever the server reboots. And there are probably some additional rules that they have running in there. I believe, let me double check. Okay. Yep. So that makes perfect sense. If it has black text and a green background like the TMP, it means that people can read and write to it other than the owners. So anybody can read and write to it. And in fact, you do utilize that temporary file when you're playing later levels, because you'll need to make a directory in there in order to store some temporary stuff in order to mess around with it. So yeah, that's what that means. I'm glad you asked, though. Okay, so let's see what we got here. Let's go ahead and do our search again, and just keep in mind, as a fair warning, we're going to get a fair number of results. Boop. Now, here's the deal. There is a way that we can narrow this all down so that we get the results that we're looking for without all these stupid error messages. We can basically suppress the error messages just in case we need to. But I'm just going to skip that for now, because there's another easy way to notice an odd one out. And that is, anytime we get an error message, it is preceded by the name of the command. If we get an error message when trying to use cat, cat will give us an error message. It'll say cat, colon, and then the error message. If we try to use base64 and we get an error message, it'll be base64 and then a colon and then the error message. If we try to use ls, ls, colon, error message, so on and so forth. So we know these are error messages because they start with the find. Scrolling up just a wee bit, you can see one right here that does not have find preceding it. Just one. We go up to the top, they're all find. If we go down to the bottom, they're all find. In addition to that, let's look at this name, bandit7.password. Hey, that's pretty promising, right? Let's see it. First, let's check the permissions. ls-l /var/lib/d package/info/bandit7.password. Tab to autocomplete. Hit enter. All right. Owner is bandit7. Owning group is bandit6. 33 bytes in size. We have a winner. Let's cat it. There we go. Just took a few tab completes. So let's cat it. Bink. And look at that. That looks suspiciously like a password. Let me go ahead and highlight this. And I'm going to go ahead and paste it into the chat box. And we're done with bandit6 and ready to move on to bandit7. Now I'm going to teach you another little trick. So remember last time I was right-clicking on the thing up here and I was saying duplicate session and it would open up a new window, but it would be going to the same location and I could just log in as bandit whatever I needed to log in as and so on and so forth. There's an even faster way to do it, and it's kind of a necessary way if you're using a macro Linux system because they don't really function like PuTTY does as far as the terminals are concerned. So let me show this to you. We are going to use the SSH command that either you've already used or that you know that people who have been using Mac and Linux systems are using. So it's going to be SSH bandit7 at localhost. You might be going like, whoa, what? What's going on here? Or maybe you're like, meh, whatever. But anyway, SSH is the secure shell command in order to open up a secure shell connection to whatever. That's what we've been doing since day one insofar as over the wire is concerned. Localhost refers to the computer that you are currently connected to. That's exactly what that means, the computer you are currently connected to. So we're asking the computer that we're currently connected to connect to itself. If we weren't connected to this computer, that is to say, if we weren't on the bandit.labs.overthewire.org and we tried to SSH to localhost, we would be trying to connect to ourself, which is silly, but it's totally doable. Like if you're on like a Linux system or something like that, like you can SSH into yourself as another user. It's weird, but it's possible. And then the bandit7 at, I mean, what does that remind you of? Maybe like email, right? So-and-so at gmail.com. User at domain is what that is. The user is the first part of the email address, then the at separates the user from the domain, which is where that email address lives. In this case, gmail.com. Well, not in this case. In this case, it's localhost. It's not actually email either. But like in my example, gmail.com. So user at location. So what we're saying here is we want to SSH. We want to SSH as bandit into localhost. So let me go ahead and hit enter. And it's going to ask us, oh, hey, this the authenticity of localhost cannot be established. ECDSA key fingerprint is blah, 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 blah. That's fine. That is exactly the same error message that popped up if you were using PuTTY or Terminal and you were first connecting to Bandit Labs. It's the exact same error message. The only annoying thing about this particular means of connecting to the next level is it doesn't save it because we can't write to the computer that you're connected to. But that's okay. We're just going to hit yes. You'll just have to hit yes each and every time you do this little trick. And then I'm going to right click in order to paste the password. And look at that. We are now connected as Bandit 7. So let's see what Bandit 7 has for us. What's Bandit 7? The password for the next level is stored in the file data.txt next to the word millionth. Well, that's pretty straightforward, right? I mean, all we need to do is just find the word millionth, and then the password's going to be right next to it. And it's stored in the file data.txt. They even tell us where it's going to be. That's amazing. All right, well, let's ls. And look at that. It's even in the folder that we started in. Extra amazing. Let's just go ahead and cat this. All right, and this is not an error. That is how many lines this file has. That is to say a lot. I believe my line buffer is, it's either 200 or 2,000 lines. And I'm not about to count all this. It looks probably more like 200 lines. And I can't even go all the way back up. So this this file data.txt is longer than 200 lines. Judging by how long it took for it to scroll through everything, much, much longer than 200 lines. Let's go ahead and file data. Actually, let's du data.txt, and we'll give the output in bytes. 4,184,396 bytes. This is a text file that is 4 megabytes in size. Just about. 4 megabytes. Remember that text file, the last text file that had a password in it, and how it was only 33 bytes? This is 100,000 times larger. Over 100,000 times larger. This text file is probably 50,000 lines at least. So we're at a bit of an impasse because even if we could scroll all the way back up to the top of the text file when we first input the command to read this file, we would have to wade through thousands and thousands and thousands of lines of text in order to find the word millionth. Not exactly ideal. There's got to be an easier way to do this. Well, you all have used Word before, or Google Docs or something like that, right? You all know that there's a Control F. I mean, you've used a browser before. The browser has Control F. You can Control F for a word on a page and it will find it for you. Well, that exists here too. It just has a funky name. It's called grep. Grep. I'm not entirely sure what grep stands for. General read something parse. I don't know, but grep is our Control F or our Command F for this thing. We can look through individual files in order to find whatever we're looking for. And the way it's structured is like this. So grep, and then the word you're looking for, and then the file you're looking for it in, file or files. So this is going to be grep space millionth space data.txt or text. Hit return, and we get one result. It reads through that entire file, finds exactly what we're looking for, and prints out one result to the terminal. Amazing. We now have our answer. CVX2JJA4CFAL TQS87JK27QW QGHBM9P1LV. We've got our password for the next one. And all we had to do was just type a single line. So send. There you go. That's your password for the next one. And I know this might probably seem a little bit cheap, but at the same time, I want to make sure everybody's on the same page. So, okay. We're ready for the next level. And we just do our little trick. SSH bandit 8 at localhost. And this is what I mean by it doesn't remember. You'll just have to say yes each time, even though we're connecting to the same thing. Right-click to paste, and we're back in. Now we're in as bandit 8. We got another data.txt. Whoops. Ugh. What are we looking at? This is horrible. Let's check out. Password for the next level is stored in the file data.txt and is the only line of text that occurs only once. All right, so we got something to work with at least. There are a list of commands here, commands you may need to solve this level. Take a look at those. If you have an idea as to what might fix it or what might do the trick, what we're looking for, go ahead and throw it into the question box. I'm going to grab some water real quick before I start coughing my brains out because of speaking too much and dry throat. Okay, so looking at the commands that are listed under commands you may need to solve this level, does anything seem to stand out as maybe useful? Just like, I know that seems kind of far-fetched, but you might be able to make an educated guess as to what would be a useful command based on what we're looking for and what the words kind of hint at. Okay, well, that's fine. So, I'll tell you right now, the first one we're probably going to look at is this one right here. Well, yeah, actually you do, but we'll get to that. You totally do, though. But yeah, let's take a look at this one. So this UNIQ, what does that look like? What sort of word does that resemble? Yeah, exactly. And let's look at this. The password for the next level is stored in the file data.txt and is the only line of text that occurs only once. Sounds like it might be right up Unique's alley. All right. Unique data.txt. data.txt. Well, that didn't really seem to do anything. All right, let's check the manual page for unique. I swear I'm not being a misogynist when I say that. Man unique. Unique, report or omit repeated lines. Hey, so that sounds like that's exactly what we need, but why isn't it working? Well, first things first, there's this option down here, U, which is the only print unique lines. Okay, so good start. But let's take a look at this description here. Filter adjacent matching lines from input. Okay. How many lines of text do you think are identical and right next to each other in this file? Probably not a whole lot, huh? Probably like a whole none of them. So we need some way of sorting them, because we need to make it so that the identical lines are right next to one another so that unique can do its job. Since again, it filters adjacent matching lines. That is to say, it checks the lines above and below it to make sure that it does or does not match them, and if it does, it removes it from results. So we need to organize them first. And that's where sort comes in, Hannah, actually. So let's sort. Let's check out man sort. Write sorted concatenation of all files to standard output. Mandatory arguments to long options are mandatory for short options too. Ordering options, blah, 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 blah. But write sorted concatenation of all files to standard output. Sounds kind of fancy, but sort lines of text files sounds like it's right exactly what we need. So let's go ahead and sort data.txt. Whoa, that's beautiful. Look at that. Look at this wonderfully sorted text file. Isn't that something? So far so good, right? We've sorted it. All right, cool. Let's go ahead and unique it. Why didn't that work? Well, okay. Imagine you have a friend. That sounded meaner than I meant it to. Imagine one of your friends is sitting there with a piece of paper. You can't see what's on the paper. You can ask him to show you the paper and you can look at the paper and that's fine. But he has a piece of paper that he's holding in his hand, or she's holding in her hand. This piece of paper in this analogy is data.txt. And you go, okay, friends, organize all of the lines on data.txt. And they go, okay, friends. And then they start reading out to you all of the lines in order after, like a fraction of a second. They just start going blah, 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 and start reading it off to you. They haven't actually changed the order of anything on that piece of paper. See, there it happened in the middle school class too, I know. But I'm trying to, I want to show you this one thing too. But yeah, nice work. This will help save your eyes in the future though. So they haven't actually done anything to that piece of paper, right? That piece of paper is still organized exactly the same way. So when we went, okay, now find all the unique things, what they did is they read off that piece of paper again and they go, okay, nothing's unique. So what we need to do is we need to change the inputs to unique. So far we haven't done that. We need to make sure that the input to unique is the sorted output on data.txt. Tricky thing is, sort just writes things to the screen, like your friend just reading it off out loud. It's not actually changing the contents of the file. Now, we're going to utilize something called pipes. Pipes are pretty useful. So check out the / key on your keyboard right below the delete key. See how you got that little vertical line above it on the same key? Hit Shift / You get a vertical line on your computer. This is the pipe. Sort of an adorable name because it kind of looks like maybe a pipe. But it's called the pipe because it allows you to pipe data from one command to another. It allows you to string together commands to run them like a combo in a fighting game or something like that, you know? So what we're gonna do in this situation is we're gonna say, okay, sort them and then find the unique ones and then give me the unique ones. You're saying this to your friend, and ideally it should come out just right. So let's say sort data.txt pipe. So as you can see, I hit space and then put in my pipe and hit space again. I'm going to say unique. Let's see what happens. So we still get a whole bunch of results. But remember what I was saying initially about how we have to add that unique option to unique? Weird that they do that. But unique -u then omits every line that has a duplicate somewhere in the text file. So now we've sorted everything, and then we've run unique on it. And our final result is the only is the only string that has one instance in that file. And thus is our password. There you go. There's your password for bandit9. So now we're gonna, SSH bandit9 at localhost. Enter. Yes, we're gonna accept the certificate. Right click. We're in bandit9 now. So let's see what exactly is going on in bandit9. The password for the next level is stored in the data.txt file in one of the few human readable strings, beginning with several equal sign characters. Curious, curious. There's our data.txt. What do they mean by human readable? Well, if we run a quick file on it, we can see that it is a data file. It's not a text file, even though it has .txt at the end. And that's one of the tricky things about the Unix command line, is they don't care about file suffixes for the most part. There are a few programs that do, and you'll learn that as you get further along in this. But for the most part, cat does not care about file suffixes. Does not care. Don't care. We can, in fact, cat whatever we want to, like our data file, and we're going to get this nonsense. Let me scroll up. What? What exactly is that? Well, I'll tell you. So imagine you and your friends. Yeah, what are the lines that are blurred / covering? What do they mean? Exactly. Okay, so imagine you and your friends invented your own code, like a secret code or something like that, and it was expressed like so. You had 1 through 9. Let's say 1 through 6. And they each represented a different thing. So 1 meant hi, and 2 meant bye, and 3 meant yes, and 4 meant no, and 5 meant if you hold down Control and hit C, you might be able to break yourself out of whatever's going on there. For sure. You know, and cat and then dog. Well, first of all, it would be just an awful secret code for many, many reasons. But, you know, let's say like, oh, you're writing like hi, yes, cat, and your friend responds with no, dog, bye, and then you have one of your other friends that's trying really hard, and they're all like, hi, cat, and then they put an 8 in there? What does 8 mean? That's not part of your secret code, so how do you, what is, huh? It's really confusing. Well, ASCII is sort of a similar way. ASCII is kind of like a secret code where numbers represent human-readable letters and numbers. Binary numbers represent human-readable letters and decimal numbers, as say base 10. But there's an expectation here, and that is that the data we feed it plays by the rules. It only uses values that appear within our table. If it doesn't, say for instance in the case where it's something that's an executable or a data file, the computer's going to do its best to interpret it, but it's not going to do a very good job, which is where you get all this garbage from, all this nonsense. This is all stuff that doesn't play by the ASCII rules or the Unicode rules. This is probably, I believe this is ASCII. It doesn't play by the ASCII rules, and thus just basically is a garbage output. So what we need to do is we need to find where the strings actually are, the stuff that makes sense, the stuff that does play by the rule. And thankfully, there is a very useful command that does that for us, and it's called strings. So if we strings data.txt, we will get written to output all of the strings that exist inside of data.txt. Basically all the stuff that's none of this nonsense, blurry, whatever. Hit enter, all these strings. And is one of the few human-readable strings beginning with several equal sign characters. I wonder what that could be. What do you mean? What do you mean that could be the password? I don't know, sorry. Anyway, that's the password. In fact, if we scroll up, we can see the 6, password, ism, and then there's the password. And there's the password to get into Bandit 10. So let's SSH into Bandit 10 real quick. Not 12, 10. Don't be me. Yes, boop. Oh, wait, what? There we go. I copied it incorrectly. Let me make sure I paste to you guys properly. Okay, that does look identical. I just wanted to make sure. Okay, so now we're in Bandit 10. The password for the next level is stored in the file data.txt, which contains base 64 encoded data. So let's go ahead and cat data.txt. I know I use data.txt and data.text interchangeable. TXT is just short for text, so I'm going to do that. I'm sorry, I'm really not trying to confuse things anymore. It's just a thing that I do. What is this nonsense? This looks kind of like a password, except our passwords really haven't contained equal signs in the past, and this also looks way too long to be a password. Well, base 64 just basically, okay, so there are a number of different ways to count if you're a computer. If you're a human, too, really, there's no limit to how you can count. We count in base 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We start over at 10 and we go around again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on and so forth. Pretty straightforward. We're all used to that. What would base 3 count look like? Well, it'd be like, let's say base 4. So base 4 would look like 1, 2, 3, 10. 11, 12, 13, 20. Wait, what? 21, 22, 23, 30. Base 4 means that we start over again at 4. Base 10 means that we start over again at 10. If you want to think of it like that, you know, we start counting at 1 again. And then we go up through all the numbers until we hit 10 again, and then we start all over again. You guys are very familiar with base 10. You guys have been doing it forever. Stuff like this is going to look super weird. That's okay. Base 2 is binary. 1, 10. 11, 100. 101, 110. 111, or excuse me. Yeah, 111, 1000. 1001, 1010, 1011, 1100, 1101, 1110. Things start to get a little wonky here, right? But by and large, this follows a very strict convention. The reason why binary is very weird is because we didn't continue far enough with the base 4 example. So like, let's see here. 31, 32, 33. We can't say 40 here because remember 4 doesn't exist in base 4. So this becomes 100. So base 64, if you can believe it, is a system where you count up to 63 before you get to 10. Sound weird? Yeah, sounds kind of weird. Well, let's take a look at hexadecimal, which is a very popular computer-wise, in terms of computers, counting system, and that's a base 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. What happened now? Well, A, B, C, D, E, F. And then 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 1A, 1B, 1C, 1D, 1E, 1F, 20. So you see where that's going? Interesting, right? So if you ever see like, 0F, 1E, A52, CB, D89, you're looking at hexadecimal. Well, more than likely. You could actually be looking at base 64, but chances are you're looking at hexadecimal. You'll see, once you start to recognize that, you'll start seeing hexadecimal everywhere, and you'll realize that hexadecimal is actually used a lot in computing. But here's the deal. So it's base 64. We need to convert it to binary so that we can interpret it properly, and we're running out of time, so I want to make sure that I give you guys basically what to do here in order to move on to the next one so that you can spend some time puzzling out the ones after that. Well, commands you may need to solve this level: grep, sort, unique, strings, base 64, tr, tar, gzip, bzip, and xxd. I wonder. Base 64 encoded data. Commands you may need to solve this level. Base 64. Let's take a look at the man page for it. Base 64 encode / decode data and print to standard output. There you go, right up our level, right up our alley. Minus D, decode data. Okay, so let's do it. Base 64 minus D data.txt. Look at that. The password is IFUKWKG-FW8MOQ3IRFQRXE1HXTNEBUPR. That was actually kind of fun to say. But yes, so what we did is we converted it from a base, from letters based on a base 64 counting system. Actually, this is base 64 right here. We converted it from base 64 into binary. And then the binary translated nicely into useful characters. So there is your password for Bandit 11. And that's going to do it for today. Now, I'm going to go ahead and leave it open for question and answer time in case you have any. I'm going to skip the poll questions just because we're running down so close to the wire, and I'm not going to keep you guys here necessarily in case you do have questions. But yeah, if you have any questions, I'm here. Otherwise, you're more than welcome to head out. Have a wonderful couple of days, and we'll see you on Wednesday.